So we are talking about limits and we've looked at a lot, right? And now we are come to talk about squeeze theorem or the sandwich theorem. I love squeeze theorem so much because basically when I'm teaching and I'm talking about squeeze theorem, I enjoy it, right? So let's look at squeeze theorem. So squeeze theorem is like we have three functions, f, g, and h, and then they are squeezing like this. Like I mean, this guy is in between this and that, right? Then what can we say about this? What we can say is now we are assuming that limit as x is approaching a of f of x is equal to the same thing as limit as x is equal to approaching a of h of x, and this are equal to L. So if the limit on this side is L and limit on this side too is also L, then we conclude that limit as s is approaching a of g of x is equal to L. So the sandwich and then the squeeze theorem is basically something like the left and then the right, because I can say that this is on the left of the function and this is the right on the function. But basically here, you are not going to see some like we finding limit on the left side and finding limit on the right side. So basically that is the only difference with the squeeze theorem here, right? And I can give an example where I find myself in a quiz room where I have 2 billion students, one here, one sitting at my left, one sitting at my right, and then let's assume that we are dealing with objectives, and then I ask the one at the right, and then he's saying that the answer is A. I ask the one on the left too, he's saying that is A. Then definitely I'm also going to shade A. But the confusion sets in when the right is saying that it is A and then the left is saying that it is B. So basically, that is the idea. It means that for me, that I don't know the question, I don't know which one to choose. So basically, that is the squeeze theorem. So it should be having the right and then the left the same before we can conclude on this. Good. So if I have the function f of x less than g of x less than h of x, then this is how it works. I pick limit x is approaching a of f of x less than or equal to limit x is approaching a of g of x less than or equal to limit x approaching a of h of x. Now we are assuming that this is L, and then limit x is approaching this, and then we are also assuming that this guy is also L, right? Then we can see that the left is the same as the right. So now this implies that limit x is approaching a of g of x is also equal to L. So that is the squeeze theorem. Now let's take examples to master what we are just trying to say. So now with squeeze theorem, one thing that we need to know is we know that trig functions sine and cos are bounded by -1 and 1. So when you look at the graph for sine, sine is basically something like this, right? It's bounded by -1 and it's bounded by 1. And when you look at cos, cos is also basically something like this. And it's also bounded by 1 and bounded by -1. So that is the idea. So we use this to work with squeeze theorem. Now let's set up. Now first, we have f of x, which is equal to this. Find an inequality for the squeeze theorem in f of x. So this is how the setup will go. Since the function is in terms of cos, I need to think about the bound here. So first I say that I know that cos of theta is the same as this. So cos is basically in between this. Now when I look at sine 1 over x to the power 4, we can see that when I compare this to cos of theta, I can see that theta is equal to this, right, from the question. So I can say that my next step will move to -1 less than or equal to cos 1 over x to the power 4 less than or equal to 1. So we want to set up f of x. But we are not done with f of x because this is what is here. But what is here is multiplied by x to the power 4. So I need to multiply through by x to the power 4 so that I have it. So this is going to be minus x to the power 4 less than or equal to x to the power 4 cos 1 over x to the power 4 less than or equal to x to the power 4. And this is the same as minus x to the power 4 less than f of x less than or equal to x to the power 4. So we're able to set up the inequality in this form, like this form. So we're able to form something like this, that we have one on the left, one in the middle, and the one on the right, which is the same as the function that we have here. So whenever they ask you to set the inequality, this is how you need to go through the process. Now apply the squeeze theorem to evaluate this. Good. So now what we just need to do is we need to pick this one, minus x to the power 4 less than or equal to x to the power 4 cos 1 divided by x to the power 4 less than of this. So when you look at what we are doing at B, we can see x to the power 4 and this, the same thing here. The only thing that is missing is limit as x is approaching 0. So what we just need to do is pick limit as x is approaching 0, pick limit x is approaching 0, pick limit x is approaching 0. So I'm going to have limit x is approaching 0 of minus x to the power 4 less than or equal to limit x is approaching 0, x to the power 4 cos of 1 divided by x to the power 4 less than limit x is approaching 0, x to the power 4. So now let's evaluate this. So here I set x to be equal to 0, I plug it in. I have minus 0, 4 less than or equal to limit x is approaching 0, x to the power 4 cos 1 over x to the power 4. This one set x to equal to 0, 0 to the power 4. So what do we get? We get 0 less than or equal to limit x is approaching 0, x to the power 4 cos 1 over 4 less than or equal to 0. So since this is 0, this is 0, this implies that limit x is approaching 0 of x to the power 4 cos of 1 over x to the power 4 is equal to 0. Now, one thing that you need to know is if we can even do direct substitution. If the question is saying that use the squeeze theorem, you need to use the squeeze theorem because it is something that we are asking you to use. But here, if we cannot do direct substitution, because when I put 0 here, I got 1 over 0 and it blows up. Yes, so this is squeeze theorem. Let's take different example. So the first example, we set up this. The question asks us to set up before doing this. But now with this one, the question is asking us that if the function is this, we should apply the squeeze theorem to evaluate this. So since they've not given us something of this form, then we need to form it. Now we know that sine is also between minus 1 and 1. So let's start with the same assumption. We know that minus 1 is less than or equal to sine theta less than or equal to 1. Compare this to this. We see that theta is equal to 1/2. So I'm going to have, sorry, I said 1/2, 1 over x. So I'm going to have minus 1 less than sine 1 over x, that. Then when I'm finished forming this, which is the same as this, then I need to solve it in such a way that I have the same thing here. So I'll multiply 2 by x, and I'm going to have minus x less than x sine 1 over x less than x. Indeed, this is very nice. Then this is the inequality formed. Then since we want to apply the squeeze theorem, we see that this is the same thing as this. So we need to take limit as x is approaching 0. So let's do that. Limit as x is approaching 0 minus x less than limit x is approaching 0, x sine 1 over x less than or equal to limit x is approaching 0, x. So now let's plug in the 0 here, and we are going to get minus 0 less than or equal to x is approaching 0, x sine 1 over x less than or equal to 0. So what do we get? This will be 0 limit x is approaching 0, x sine 1 over x less than or equal to 0. And this implies that limit as x is approaching 0, x sine 1 over x is equal to 0. So this is very nice. It's not always the case that the left and then the right is going to be 0. This is kind of fortunate. So if the right, let's assume that if this one is 1, then we can conclude that this does not exist at all. That's all we need to do. But since they are all 0, 0, then this is equal to 0. Let's take another example. I think this will be the last example, then I'll give you one to try. Now we want to find limit as x is approaching minus 1 of f of x, but this one they form the squeeze theorem for us. So let's do this and see. But one thing that we need to pay attention here is, now we want to find limit of this, but the one in the middle is not the same as this. Look at this one here. Before we took the limit, before we came to this step, we saw that what is here is the same as what is here. So since before we take the limit, we need to make sure that what is here is the same as what is here. But what is here is f of x, and what is here is f of x over 2. So to make this one f of x, we need to multiply 2 by 2 so that we can take this one out. So multiply this one by 2 less than or equal to 2 times f of x divided by 2 less than or equal to 2 times x squared plus 2x plus 2 divided by 2. And then this cancel this, this cancel this, this cancel that. So we are going to have 1 less than f of x less than x squared plus 2x plus 2. So now we can see that the one in the middle is basically what is here. So now we can pick the limit as x is approaching minus 1. So limit x is approaching minus 1 of 1 less than limit x is approaching minus 1 of f of x less than x limit as x is approaching minus 1 x squared plus 2x plus 2. Now this limit of a constant is the constant, and then the middle we are going to have the same thing there, less than or equal to. Now this one we set s is equal to minus 1, we plug it in because it's a polynomial function. So I have minus 1 squared plus 2 times minus 1 plus 2. Let's see what we are going to get. Limit x is approaching minus 1, f of x less than or equal to, this is 1 minus 2 plus 2. This is this x minus 1 f of x, and this will be 1. So this implies that limit x is approaching minus 1 of f of x is indeed 1, because the left and the right are the same. So this is Squeeze Theorem, and these are, I think, all the basics that you need to understand this. So I want you to try this and put your final results in the comment section. So try and use the sandwich or the Squeeze Theorem to evaluate this. Set up your inequality, and when you are done, try to use the same idea that we've learned to solve this question. I hope you are here with me enjoying this nice tutorial, and then we'll finish limit soon and we are going to start derivative. So see you in the next video.